Welcome to this training session on building internal competency for auditing advanced algorithmic systems. We will cover the foundational knowledge, specific technical areas, and practical skills required to evaluate these modern technologies effectively. Let us discuss the real-world utility of mastering this topic. By understanding these core concepts, you will be able to confidently step into any procurement meeting and evaluate whether a vendor's new smart application is secure enough for your company's data. You will also possess the vocabulary to ask the right questions, ensuring your organization avoids the legal and reputational disasters that come from deploying unchecked or biased algorithms. Before you can train an audit team, the entire organization must agree on a single definition of what artificial intelligence actually means for the business. You might adopt a definition from an established framework like the Organization for Economic Cooperation and Development, or a major regulation like the European Union Artificial Intelligence Act. The most crucial distinction to understand is that these systems are not programmed in the traditional sense. Traditional software follows a rigid set of rules provided by a human. Artificial intelligence systems, however, are designed to be trained using data. Think of traditional programming like baking a cake using a strict recipe. You add 2 cups of flour, bake at a specific temperature, and get the exact same cake every time. Training a modern algorithm is more like teaching a child to recognize different types of animals. You show them hundreds of pictures of cats and dogs, correcting them when they are wrong, until they learn the visual patterns on their own. Since the surge in public awareness following the release of consumer chatbots in late 2022, many people use technical terms interchangeably, but an auditor must be precise. Let us clarify the hierarchy of these technologies and the scope of their capabilities. First, we have artificial intelligence, which is the broadest category. This is any advanced computer system that can simulate human capabilities based on predetermined rules. Inside that broad category is machine learning. This is a specific type of program that builds a predictive model by feeding on input data. And deep within machine learning is deep learning. Deep learning utilizes highly complex, layered structures to process information, similar to how human brain cells connect. Imagine a massive transportation system. Artificial intelligence is the entire concept of moving people from place to place. Machine learning is specifically the trained networks within that system. Deep learning is the highly complex, high-speed bullet train operating on the most advanced tracks. Now let us look at the scope of capability, starting with artificial narrow intelligence. This is a system restricted to one highly specific area of knowledge. Every commercial system in use today falls into this category. It simulates human thought, but only for its assigned task. Think of narrow intelligence like a world-class pastry chef. They make incredible desserts. But if you ask them to fix your car engine, they cannot help you. In contrast, artificial general intelligence is a theoretical concept. This describes a system capable of undertaking any intellectual task a human can perform, including emotional engagement, fine motor skills, and creative problem solving. Using our analogy, this would be a super mechanic who is simultaneously a world-class chef, a surgeon, and a composer, possessing limitless adaptability. To successfully audit these environments, professionals must develop a multidisciplinary skill set spanning 10 specific areas. Let us explore each one. First is technical knowledge. You must understand foundational concepts like natural language processing, which is simply how a computer reads and generates text, and computer vision, which is how a machine interprets images. Second is grasping basic concepts and terminology, especially how they align with industry standards and regulations. Third is familiarity with common models and applications. You do not need to build them, but you must recognize the commercially available tools your business is likely to purchase and use. Fourth is bias. Because these systems excel at finding patterns, they often accidentally learn human prejudices hidden in the data. Bias is usually an unintentional design flaw. Imagine designing an automated resume screener that only selects candidates from a specific university because historical data heavily featured that school. The algorithm is not malicious, but its outcome is discriminatory. Auditors must test outcomes to mitigate this risk. Fifth is governance. This refers to the overarching framework of policies, management, oversight, and controls that hold the organization accountable for its algorithmic tools. Sixth is ethics, which is divided into applied and theoretical branches. Applied ethics deals with fairness, privacy, and human rights in everyday operations. Theoretical ethics studies deeper moral obligations and dilemmas, like consequentialism. Consequentialism simply means judging the morality of an action by its final outcome. Think of theoretical ethics as the philosophical debate about building a dam, while applied ethics is ensuring the water flow does not unfairly flood a specific neighborhood. Seventh is trustworthy design. This framework ensures technologies are transparent, secure, and reliable, prioritizing human welfare above all else to prevent harm. Eighth involves specialized risk assessment frameworks. These tools introduce entirely new hazards. For instance, an auditor must now evaluate the risk of discriminatory harm caused by bad training data, something rarely considered when auditing traditional accounting software. Ninth is understanding audit-specific applications. This means knowing how you can use these smart tools to make your own auditing processes faster and more accurate. 10th, and finally, is regulatory and compliance knowledge. You must stay updated on the laws governing algorithmic use specific to your geographic region and industry. Bridging the gap between theory and actual auditing requires practical skills development. Because this field requires knowledge of information technology, data science, and business strategy, it is a highly collaborative effort. Auditors must exercise professional judgment to decide which tests apply to specific environments. To build this muscle, continuous education is mandatory. The technology evolves too fast for annual, static training. Organizations should heavily utilize case studies and real-world scenarios. Even more effective are simulation exercises. Think of a simulation exercise like a corporate fire drill. You create a hypothetical scenario where a major algorithm goes rogue, and cross-functional teams must collaborate to assess the damage and audit the failure in real time. If an organization lacks internal expertise to run these simulations, bringing in external experts is a highly effective way to close those knowledge gaps and elevate the entire enterprise. Let us recap the key takeaways from this session. We started by emphasizing the need for a universally agreed upon definition of these tools within your organization, noting that they are trained via data, not rigidly programmed. We defined the hierarchy from broad artificial intelligence down to machine learning and deep learning, and distinguished between current narrow intelligence and theoretical general intelligence. We thoroughly examined the 10 critical knowledge areas, highlighting the importance of bias testing, governance, and the 2 branches of ethics. Finally, we discussed the necessity of continuous, practical skills development through cross-enterprise simulation exercises. All the important topics and concepts from this session are covered in the multiple choice questions on RooCloud.com. You should ideally solve the chapter-wise questions to reinforce your learning before moving on to the next session. Thank you for watching, and I will see you in the next episode.